In 1984, a committee tried to make every computer on Earth speak one language, splitting it into 7 invisible layers you use right now. Your video call just froze. Was it your Wi-Fi, your router, or something buried deeper in the network? Stick around, you'll find out. That framework is called the OSI model, built by the International Organization for Standardization to end a chaos of incompatible networks. 7 layers, stacked like floors in a building. Each floor does one job and passes its work upward or downward. Engineers remember the order with a phrase, "Please do not throw sausage pizza away." Silly, but it sticks. Let's start at the bottom, the ground floor, where information becomes nothing more than electricity, light, or radio waves. This is the physical layer. Copper wires, fiber strands, Wi-Fi signals, even the vibration of a cable in the wall. No meaning exists here. Just voltage, ones and zeros as pulses of light racing through glass at incredible speed. In 1956, the first transatlantic telephone cable carried 36 voice channels under the ocean. That's physical layer thinking, ancient but alive today. Above that sits the data link layer, and here's where things get organized, packaged into frames with addresses attached. Every device has a MAC address, a unique 12-character tag burned into its hardware, like a fingerprint. Switches live here, reading those addresses, deciding which cable or frame should travel down next in microseconds. Ever wonder why 2 laptops on the same Wi-Fi can talk instantly without asking permission? Thank the data link layer. Now we climb to layer 3, the network layer, and this is where the internet actually becomes the internet. Here, IP addresses take over. Not hardware fingerprints, but logical addresses that can change, like a mailing address for a moving truck. Routers live on this floor. Their entire job is choosing the best path for your data across thousands of possible routes. In 2023, global internet traffic reportedly hit around 150,000 petabytes a month, all routed through decisions made at this layer. Think of the network layer as a postal system for machines, sorting envelopes by zip code, except the mail moves at light speed. Layer 4 is the transport layer, and this is where reliability gets decided, whether your data cares about perfection or speed. 2 protocols dominate here. TCP double-checks every packet arrives, resending if lost. UDP just fires and forgets, prioritizing speed. Video calls often use UDP. A dropped pixel doesn't matter much, but a dropped bank transfer? That absolutely needs TCP. Ports live here too, thousands of them, like numbered doors on the same building, so multiple apps run without colliding. Layer 5, the session layer, quietly manages something you never think about, keeping a conversation alive between 2 machines. It opens a session, keeps it synchronized, and closes it cleanly, like a phone call that starts and ends politely. Without this layer, every message you send would feel disconnected, arriving with no memory of what came before it. Layer 6 is the presentation layer, and it's basically the translator, converting data into a format both sides understand. Encryption happens here too. That padlock icon on your browser. Part of its job is presentation layer work, scrambling your data into unreadable code. Compression, decompression, character encoding, even converting between file formats, all quietly handled before you ever see the result. Finally, layer 7, the application layer, the only floor you actually interact with directly every single day. This is your browser, your email client, your video call app. Everything visible lives here, while 6 invisible layers work beneath it. Protocols like HTTP for websites and SMTP for email operate at this level, the ones with names you might actually recognize. Here's the twist though. The actual internet doesn't strictly run on OSI. It runs on something called TCP/IP, a simpler 4-layer model. OSI was designed in 1984 by committee. Almost too perfect, too theoretical. The internet had already grown up using its own scrappier system. So why do we still teach 7 layers? Because when something breaks, OSI gives engineers a map to hunt down exactly where. Remember that frozen video call from the beginning? Here's how a technician actually finds the problem, layer by layer, from bottom to top. First, check the physical layer. Is the cable plugged in? Is the Wi-Fi signal even reaching the device? Simple, but often the actual answer. Next, the network layer. Can the device even get an IP address? No address, no internet, no matter how strong the signal. Then transport. Is the port blocked by a firewall? Some corporate networks block video call ports entirely, without users ever knowing why. Finally, application. Maybe the app itself has a bug. Nothing to do with the network at all, just bad code. That's the real power of these 7 layers. Not perfect accuracy to how the internet works, but a diagnostic checklist for chaos. Telecom companies still train new engineers on this model first, before anything else, because it teaches a way of thinking, not just facts. Cisco's own certification exams, taken by hundreds of thousands of network professionals worldwide, still open with these 7 layers, unchanged since 1984. So next time a call drops or a page won't load, picture that 7-floor building and ask which floor just went dark. Maybe it's the cable in the wall. Maybe it's a router choosing a bad path. Maybe it's just an app that crashed. Either way, the answer was never magic. It was always sitting somewhere between the electricity in a wire and the app on your screen.